Okay, this is a quick video talking about domain and range of a function. I've got a function graphed right there. The red function is what we're going to use to talk about domain and range. If you want to pause your screen real quick, I got the definition for both domain and range over there on the right side of your screen. The domain is the set of all x values or inputs used by the function, and the range is the set of all y values or outputs used by a function. So what we're going to use in this course is interval notation, because there is an infinite number of points on this graph. Every speck of red is another point, is another x and y value. So I've got points on here, but it doesn't cover all of the points that are actually on this graph. I put some dots to represent turning points in this graph, but every single speck of red is another x and y value. So we would not be able to list every single point if we tried to. But I'm going to show you what interval notation is going to look like. First, we're going to talk about domain. Again, domain is the x values used by this function. So what I like to do is look from the left to the right, because my x values are horizontal values, and interval notation uses your smallest x value and your largest x value. So the furthest to the left is this point right here, and its coordinates are -2, -3. Well, the x value is -2. So the smallest x value that I use is -2. And over here, the furthest to the right is going to be where my largest x value is coming from. The coordinates of this are, and I think we're missing a little mark here. Pardon me while I put it in right there. 1, 2, 3, 4, 5, 6. And a y value of 2. So 6, 2 would be the coordinates of that point. So that means the largest x value I would have here is 6. Now, our graph absolutely starts and stops with those points. So these brackets indicate that those points are parts of the function and parts of the domain that I'm talking about. So we have an actual point with an x value of -2. We have an actual point with an x value of +6. So those brackets indicate that those points using those x values are included in the domain. All right? Our range goes from bottom to top, the lowest y value up to the highest y value. Again, y values are vertical. So our range includes the lowest y value, which again comes from that point, -2, -3. So -3 would be my lowest. Notice again, I'm starting with my smallest y value, my lowest y value, all the way up to my highest y value, which is part of that other point, 6, 2. So +2 would be my highest y value. I never go above that. And because I have points that actually have those y values, we use brackets because those are actual points that get used by the function. All right? Now, the only change in this is if I have a function that does not necessarily start and stop, and we can look at something like that very quickly. So let me sketch you a graph where my function does not have a definite start and stop. So if I have a graph that fits onto this coordinate plane, and I've got, and I'll use a different color, looks something like maybe I've got a point here, and I go up to here, and then I have a function that does something like this, where it does not stop, yet it keeps going there. And I've got a point there, a point there. These are just some of the turning point things. And we could talk about domain and range for this just to give you a little bit different perspective. Again, your domain would be your x value. So I'm looking from left to right. So that will be here. And then, unfortunately, that does not stop going to the right. It keeps going and going and going. But this point here definitely is a starting point for us. So the x value of that would be positive 1, and the y value would have been negative 3. So the x value, or my smallest x value specifically, would be positive 1. But because it continues to go to the right, up and right forever, it never stops. We say that it's heading toward positive infinity. That sideways 8 is our infinity symbol, and it represents a place beyond where we can count. So infinity is not an actual place or a number, but it represents beyond what we can count. Well, we have an actual point at our smallest x value, so we use a bracket on that like we did before, but because infinity is not a definite place that we go to, we use a parenthesis on it. So because there's not a point part of our domain that has an x value of infinity, we use the parenthesis there. And then our range would be dealing with our y values, and both these 2 points here, and this point here has a coordinates at 3, negative 3. They both have the same y value, and it's our lowest y value, so we'll start with that. And since they're definite points, we'll put a bracket on that. But our graph does seem to go up forever. So because it goes up forever, we go with positive infinity as well. But because there's no point that has a y value of positive infinity, we would use the parenthesis on that. Remember, if you're going down forever, that would be the negative infinity piece. So for this example, we have these arrows which indicate that there is no stopping. This graph just continues to progress down and to the left and down and to the right. So that brings infinity into our discussion for domain and range. So let's first take the domain. That's the x values from left to right. So it's going left and down forever. So there is no smallest x value. So we'll go with negative infinity. And there is no largest x value because I'm going right forever, and that's going to be positive infinity. Again, parentheses because there is no point with an infinity as its x value. For my range, I go down forever, so that means there's no lowest y value, so negative infinity would be the smallest y value. But I do have a maximum. 4, 3 is my maximum, which means that 3 is my largest y value, so I'll use that for my range. And because there's a point with an actual y value of 3 in it, we use a bracket on that. So this is how infinity can come into our discussion for domain and range.